All right. So welcome back, everybody. I know some of you were out, some of you were out on a break, some of you were worrying about school starting soon, but part of life. Okay. So, what are we going to learn today? Hey, Vishal. Any guess? Okay, so we'll start with a concept or a unit called limits and continuity. What is it? What does it actually mean to anybody? When we talk about limits, let's start with limit. Continuity is like, okay, you guys attending the class every day, every class, continuity. Having some break due to family breaks, family vacations, that is not continuity. So anyways, that is the English part of it. But let's try understanding what do we mean by limits. And I would want to hear everybody's opinion. What do you guys know about it? Praneeth, Hasmita, Dhanushri, Tanvi, Vishal, and Arush and Sahit in the class. Any guess? Make a blind guess, that's okay. Yeah, Praneeth.
Stopping point.
Like a stopping point. So as I keep saying, right, Tanvi, any thoughts, beta?
If it's related to graphs, then like a limit could be like Pranit said, like a stopping point on the graph. Like it's ending, but continuity can be like a repetitive one, maybe.
Okay. Now, Dhanushri, any thoughts? Hasmita, any thoughts? Don't restrict your thought process, okay? Go as creative as you can.
I think the same thing.
Same thing. Okay. Now let me give you guys one classic example. If I say y as a function of x, and it's a function of x, is equal to x minus 3 over x minus 3. What does it mean to you? What is the value I'm talking about for this function? No, just think about it. It's a very simple question, okay? I'm saying function of x equals x minus 3 by x over 3. What does it mean? Mathematically think about it. Yes, Pradeep. 1. Okay, so it means this equals 1, something by something, same thing, 1, right? Very normal way of looking at it, correct? Now, let me give you guys some food for thought. Okay, so x over 3 by x over 3 equals 1. Now I'm saying no, that is not true always. Like you say 5 over 5 is 1. You're saying so x minus 3 over x minus 3 is 1. And I'm saying, you're partly correct, but not always. Yes, Arush.
And if x is not equal to 3, it's 1.
You're right on money. Okay, so what Arush is saying is, yes, x minus 3 over x minus 3 is 1. Is not correct, it's almost correct. Now, what does it mean? When x equal to 1 or even 0, you'll put a 1 here, 1 minus 3 is minus 2, over 1 minus 3 minus 2. Minus 2 over minus 2 is 1. No worries. If you put x equal to 0, it becomes minus 3. Minus 3 over minus 3 is again 1. No problem. But the problem happens as soon as you put x equal to 3, it becomes 3 minus 3 over 3 minus 3. 0 over 0. A unique situation of being undefined. So this function becomes undefined for a situation like this. Likewise, many functions that we will deal with, you will see that at certain points, it is undefined. Now, what does it mean? Everything was going fine, life was okay, fun. You started from x equal to 0, no worries. You went to x equal to 1 for this function, no worries. X equal to 2, no worries. X equal to 2.5, no worries. x equal to 2.8, no issues. X equal to 2.9, nothing to worry. X equal to 2.999999, no issues. As soon as you hit x equal to 3, life changes upside down. It became undefined. Yeah? Our basic concept of something over the same thing being 1 got proven wrong. But it's not so bad. And can you guys see the board okay? I hope there's not too much of a glare for you guys. Okay. Now, it has not changed too much. When you say x equal to 3.01, it comes back to normal. So then, and when you keep increasing it, it's still fine. The value remains 1. So it only happened for this scenario, in this case, in this function. This is math time, not ice cream time. Guys, move away. Okay. So, then we got to know about a new definition of function. This is where it says, when x equal to 3 in this case, you are saying that this is a limit. This is when you are hitting a limit where the function becomes undefined. And then you will define this as, instead of saying function of x, you will put some more spice to it. You'll say, when x is approaching 3, you added this extra flavor to it. LIM is the short form for limit. This is how you define the limit of any function. Any questions so far? No?
No, sir.
Now, imagine or visualize this in a coordinate plane. Let's say this is your f of x or y, and this is your x. If you're trying to plot this, if you look at this graph, let's say this is 1, this is 2, this is minus 1, this is minus 2. For every value of x, be it 1, 2, 3, 4, 5, minus 1, minus 1, minus 2, minus 3, minus 4, minus 5, so on and so forth, you see that your fx is pretty much along this line. For every value of x, your fx is 1, except for the scenario where you have a break. So this defines a limit, saying that the function is defined for this, but it is undefined only at this point. Yeah? So we have just plotted this function on a coordinate plane, and this graph represents that, okay, this function is not defined when x equal to 3. Yep. So you can put a blank circle here, which means if you are approaching this from left or if you are approaching this from right, at any point before this, if you are approaching from right or if you are approaching from left, at any point or a point very, very close to this, okay, very, very close to the x equal to 3, let's say you're talking about x equal to 2.99999999 if you're going from this direction, or you're talking about x equal to 3.000000001. In both the scenarios, for this value or for this value, you have function of x equal to 1. But except for limit x approaching 3. So this says except for this scenario when x equal to 3, everything else is equal to 1. Our function of x is equal to 1. So this is how you can represent that or think about it in a graph. And again, you guys will think, why are we actually stressing on something that which was very easy otherwise? Because this will become our building block when we try learning or getting deeper into calculus. Calculus deals with the situation where how your values change and what are those limiting points. So basically when we'll talk about calculus, we'll talk a lot about domain, range and all the other stuffs, and how incrementally your variables are changing in different ranges. That will be the key concept that will come across in calculus. That is why it becomes very important for us to look at these functions with a little different perspective from that limit perspective point of view. Is it making sense so far, or I'm making life more difficult for you guys? Asmita, Praneet, Tanvi, Dhanushri, makes sense? Vishal?
Makes sense, sir.
Okay. So again, I was kind of tempted to teach you guys a lot of things today, but I thought no, let's muddle the water today only with functions and limits. Let's make sure that we understand the limits from different, with different possibilities, and then we'll see if we build a very solid understanding of limits and all, so that when we go to the subsequent chapters, it will be much easier to relate. Let's look at another function. Okay, simple function, simple cute looking function, right? Function of x equal to 1 by x. If you guys have to plot it in a coordinate plane, what will it look like? Let's try doing that. Okay, 1, 2, 3, 4. Here minus 1, minus 2, minus 3, minus 4. Here 1, 2, 3, 4. This is function of x or y axis, and this is my x axis. Let's do it a very simple way. Making a table x and function of x. Let's see what happens. When x equal to 1, 1 by 1, fx is 1. When x equal to 2, 1 by 2, 0.5. When x equal to 3, 1 by 3, 0.33. When x equal to 4, 1 by 4, 0.25. When x equal to 0, infinity or undefined. Let's forget about undefined, defined kind of scenario. Let's look at in a very simple way. 1 by 0 is infinity. Yeah. Now let's look at some negative values. When I put x equal to minus 1, this becomes minus 1. When I put minus 2, it becomes minus 0.5. Minus 3, minus 0.33. Minus 4, minus 0.25. And see, I'm enjoying wasting everybody's time, isn't it? Yeah? See how happy I am wasting everybody's time by putting this table. Now let's look at little more details. Now let's try plotting it. When x is 1, y is 1. Okay, fine. This is the point. When x is 2, y is 0.5. Maybe here. When x is when x is 3, here. 4, it's coming down. Okay. More the value of x increases. And let's put one more scenario. When x equal, okay, this is x, function of x. Let's put x equal to 0.5 also. 0.5 will give 2. So when x is 0.5, it's 2. Now when you go to negative side of it, okay, when x is 0, see, what is happening is, if you look at this graph, as it approaches 0, it becomes undefined. It literally shoots in the y direction. Now look at the negative side of it. Same thing, you will see 1 minus 1 here, 1, 2, here, 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 and you will see here. So you will see an exact reflection of this thing. Okay? What you're seeing is, when you're approaching x from the left, it's going towards negative infinity. When approaching x equal to 0 from negative side, meaning you are increasing from -4 to -3, -3 to -2, you see that your fx is going towards negative of infinity. When you are approaching x, meaning from positive side towards 0, you see it going in this direction. Is this a situation where we can say that we have a limit here? See, when my x is 0, when we looked at the other equation, other function, fx equal to x minus 3 by x minus 3, what we saw was this graph was like this. And only at x equal to 3, this was undefined. So when you are approaching from left or from right, it was meeting at a point, and that point was kind of common, where it was undefined. Here you look at, when you are approaching 0 from right or from left, it's not meeting. So this is another criteria for us to remember or to be aware of, that when you have a function where your limiting value, which is x equal to 0, where the function is undefined, is not coinciding at the same point, you will say that the limit, there is no limit that exists for this guy. Here, your point where your function goes undefined, just before that and after that, it's approaching the limit. Just before a value little less than the limit and value little after the limit, they are both matching, and just that the function becomes undefined for this one, but then you still have a limit here. In this case, when your function is about to become undefined, meaning this scenario, when x equal to 0, if you are approaching from right, you see a different outcome. When you are approaching from left, you are seeing a different outcome. So you will say that there is no limit that exists for this one. See, some of you have started reading my mind. When I go quiet, immediately Tanvi and Praneeth and Vishal realized that this guy is getting worried. He is probably not convinced whether the kids have understood the concept or not. Immediately they raise their thumbs up. But yeah, jokes apart, Hasmita and Dhanushri, is it making sense, beta?
Yes, sir.
Okay. And again, I might not be making sense. It's quite possible, because I'm still trying to get you guys used to a concept that is not very common, even for me, right? I mean, if I think of it, like I always say, right? I'm not very intelligent. Meaning, I look at things in a very simple perspective. For me, this is always one. Unless I double click on this and think of different scenarios. That's what we are seeing here. That okay, it's perfectly fine, it is equal to 1, this function is giving me value of 1, except for the scenario where I'm reaching the limit of x equal to 3. Everything is fine if I'm going from here until I have reached this point. I mean, just a few millimeters or micrometers or nanometers away from this distance is everything fine. Even once I cross this hurdle and then I move the slightest distance after this, I'm still fine. This is my limit, where I have a limit for which the function becomes undefined, but I have a limit. In this case, I have a point where the function is undefined, but then there is no limit, because the limiting points are not meeting. They are not coinciding in the same place. Yeah. So, in layman's term, if I say minus 0.0000000001 is hugely different from this. As a normal human being, would I see any difference between the two? Probably not. I mean, it would not matter, right? if you convert this into a dollar, or even if you convert this into a million, then also we are talking about a pretty much ignorable number, correct? But when you look at this function, there is a huge difference. It's totally upside down. So in this situation, when you see a huge difference between the two neighboring points or neighboring values of x, that is when you will see that the function is, there is no limit here, and obviously the function is not defined on this point. Does it make sense? Does it make sense with some brutal force? Okay, no brutal force. No force for you guys, okay? Tanvi, all okay with that?
Yes, sir.
Hasmita, Dhanushri, all okay? Okay.
Yes.
So, Sahit, Arush, no question. Now, let me find out some more spice into this whole discussion that we are having. And I promise I will waste today's class only to make sure that we have no doubt around understanding of limits, because so there are two things that we are going to understand today. One is understanding the limits that we have conceptually understood, and now we are trying to relate that concept with the graph and see how do we read a graph to understand what is the limit and to understand what are the points where the function becomes undefined. Because you will find these are little troublesome topics where it doesn't align with the main course of the concepts of math, but then you will see that these are the easy pickings. If you are very clear about the concepts, you can literally just look at the question and you'll be able to get the right answer without putting any effort or without doing any calculation. Let's look at, let's say I have a function which is, let's say, x squared for a limit of, let me not put it here, saying in the situation where x is not equal to 2, okay, and this same function is equal to 5 when x equal to 2. So I have a function which says the value of the function will be equal to x squared for all scenarios except x equal to 2. And when x is equal to 2, fx will be equal to 5. Now let's look at it, what it means to us when we look at this as a graph. So let's say this is 1, 2, 3, or I'll say 1, 2, 3, 4, 5. Here I'll say 3, 6, 9, 12. I'm just using a different unit on x and y axis so that it's easy to plot. Okay. And you guys don't mind if I use different units, right? No, right? Yeah. No, because sometimes if you don't look at things carefully, people will say, what is this stupid stuff that this old man is doing here? On the x-axis you have 1, 2, 3, 4, and here you have 3, 6, 9, 12. There's a reason for it. I'm just using a different scale so that I can plot things differently. And we have the flexibility of choosing the scale that we want to choose. Okay. Now, what this says, when x equal to 2, when x equal to 2, y is 5. Okay, fine. Y is 5, maybe somewhere here. Okay, there is a point. Now let's look at this situation. When x is not equal to 2, so when I'm talking about x equal to 0, fx is 0 squared, that is 0, this is 1 point. When x equal to 1, this is 1 squared, maybe here. When x is minus 1, again same thing, 1. When x is, let's say, if x equal to 2 was not an outlier here, it would have been 2 squared 4, so somewhere here. when 3 would have been 9 here, 3 would have been 9 here. So let me try plotting it. This is my graph for fx equal to x square. But I'm saying when x equal to 2, this is not true. So I have discontinuity in this graph for x equal to 2. And then when x equal to 2, I have a different point. So basically what is happening is for x equal to 2 in this one, this function becomes undefined because you don't have, that is given as a limit here, as an outlier. This x equal to 2 which translates into 4, fx equal to 4, that point 2 comma 4 is not supposed to be on this graph. So that's why I have created a blank here. You guys can see the board okay, right? Praneeth, Hasmita, Dhanushri? Okay. Vishal? Yeah. I mean, because when I'm seeing it on my laptop screen, I'm seeing a bit of glare, that's what I'm asking. Okay. So, now if you look at this function, what is the interpretation we have? See, we still have a limit here at x equal to 2. Meaning, when I have a x value little less than, when I'm going from left to right or right to left, just before hitting this point, my value is almost the same. The function is defined. There is a limit also because there is no break. Only at this point, only at x equal to 2, it became undefined. Yeah. So basically, any function that you talk about, now let's kind of go back and look at it in a more conceptual way. And guys, just stop me if I am getting anybody worried, okay? Because trust me, these are not regular concepts. It's not 2 plus 5 equal to 7 kind of a thing, okay? It's not about solving any quadratic equation where you say, okay, this is my quadratic formula, put the value and you get it. It's more to nudge you on some of the concepts that are not part of the mainstream, okay? Little bit off track, it might sound. Now let's look at it from a practical point of view. If you have a function which plots a line like this, straight line in a coordinate plane, or like this, these are functions which are contiguous in nature. When you have a function which creates any break, these are limiting points. It says that this function becomes undefined at this point. That is what we are trying to understand. Third thing is, you might have a situation like what we saw just now. In this case, your function becomes undefined, but you still have a limit. In this case, your function is defined, but there is no limit. There is no limit here because they are not meeting at one point. The point where the function is getting disconnected, we are saying that, okay, this function doesn't have a limit. You cannot say that, okay, as soon as I approach this value, it's closing. So basically that's the difference between having a limit versus not having a limit. In both the scenarios, the functions are undefined, right? At x equal to 0, your function becomes undefined, but here you have a limit, here you don't have a limit. So continuity versus no continuity. That's how you can look at it. Yeah? Now. Okay. Now let's look at some more stuff that I had probably put in the plan. So here, there's another term that you will hear about. This was our graph for function 1 by x. Function of x for 1 by x. What happened at x equal to 0? It went out of bounds. This is called, this becomes unbounded at x equal to 0, meaning this went out of control. You have no way to kind of bring it back or relate or get them close to each other. They are called unbounded. So that is another term that you might hear very often. So it's the same thing. Unbounded or function having no limit pretty much relates to the same thing. Yeah. Now, what I want you guys to do is this. And this is one of the possible scenario, okay, that you will come across. Okay. You will say you have a function which plots let me not add too much spice. Okay. So let's say you have a function where x equal to 2, 3, let's say 5. This is, let's say, 7. And this is 2. Let me pick up a point other than this so that you guys can see it clearly. This is 3, this is 2, and this is 8, and this is, and this point, let's say, is 2.8. If you see a graph like this, what I'm saying is, in this graph, I'm just reading it because I don't think I've written it in the most legible way. For x equal to 2, you have a disconnect here, okay? Meaning, this is where this graph ends and this graph starts. At x equal to 4, you have a gap. And this is, so let me say this. Fx equal to something at x equal to x approaching 7 as a limit, x approaching 4 as a limit, and x approaching 2 as a limit. Can you guys tell me what is your reading of x equal to 7 as a point, x equal to 4 as a point, and x equal to 2 as a point? Let's see if I have been able to make any sense to you guys so far. I mean, it's reflecting on me, okay? If you guys give me right answer, that would mean I'm a good teacher. If you guys give me a wrong answer, that means I'm a bad teacher. Let's see.
What did you ask?
I'm sorry, Vishal?
What did you ask?
I'm asking, I have 3 points here, okay? This is a graph, okay? This is a graph plotted by a function of x, okay? And I have one point where x is approaching 7, okay? What does it mean? How do we define it with respect to this function or the graph that you are seeing? So we are just trying to read the graph, okay? Second point is for x equal to 4. When x is approaching 4, we have a break here. And when x is equal to 2, we know that, okay, this graph is going in 2 different directions. So when x limiting 2, x limiting 4, and x limiting 7, how do you define these 3 scenarios? What is your reading of it based on whatever we have discussed so far? I'm just trying to see if I articulated that well enough. Did I put the question okay, or I did not? I mean, did you guys understand the question in the first place?
Yeah.
I'm sorry, Vita?
Could you repeat it?
Okay, what I'm saying is this is the graph I have, function of x. And there are 3 points that I'm talking about. This is function of x for x limiting 7 or x equals 7 or x approaching 7, whatever way you read it. This is the point where we have discontinuity when x is approaching 4, and this is the point, this is the third scenario when x is approaching 2. I want you guys to tell me what is your reading of x equal to 7 or x approaching 7, that point. What is your reading of fx where x is approaching 4, and what is your reading of the point when x is approaching 2? Give it a shot. I mean, again, I know this is not a topic that will be very easy to digest in one go. So I said something. I'm just trying to see if you guys are able to relate to it. Give me some story, guys. Don't think about the story being right or wrong, or don't worry about it. Okay, let me give it a shot. Now you look at when x equal to 7. What is the value of fx at x equal to 7? Probably around 2. Fx equal to 2. Okay. When you are approaching it from left or from right, in both the scenario, it is approaching 2, and there is no discontinuity here. The function is defined. So for x equal to 2 as a limit, this function is defined, and the value of the function matches with the value of y. Yeah, at this point. Now, at x equal to 4 or x approaching 4, there is a discontinuity here. We have a limit because when you are coming from left or going from right, your values are almost matching. You only have a problem at x equal to 4. So basically, for this function, for x equal to 4, this function is not defined, but then it has a limit. Still has a limit. For x equal to 2, what you are seeing is, when you are approaching from left or from right, they are not meeting at one point. So at x equal to 2, it becomes unbound. The function is not defined for sure, and there is no limit also. Because you will say, okay, limit only happens when at that point you are approaching. It's like look at this like a ring that is connecting the two endpoints. Okay, just before this and after this. When you see that ring connecting the two endpoints, you have a limit. If you don't see a ring connecting the two endpoints at the value of x equal to 2, this becomes unbound, or you can say that there is no limit. So it was nothing. See, this question was nothing but just a recap of what we have seen so far. How do we relate to what do we mean by limits of a function? What do we mean by function being undefined? And what do we mean by function not having a limit? Yeah? So you guys saw that scenario, right? When we looked at the function of x equal to x minus 3 by x minus 3. Let me change this and say x minus 4 by x minus 4 also. This was undefined at x equal to 4. So this was a scenario where you had everything in place, but only for that particular case when x was approaching 4, just before approaching 4 and just after 4, both were fine. Only at this particular point, this was becoming undefined. And so this was a limit scenario where the function becomes function has a limit but becomes undefined at that particular point. Wherein when we looked at the function like this, we saw that this is where it was becoming unbound or function not having the limit, because at the limiting point at x equal to 0 here in this case 1 by x, the two endpoints were not getting connected through a ring. Okay, they were unbound, they were going in different direction, they were not meeting at one point, so they were undefined, and they were also not having the limits. So there are three concepts that we have to, three flavors that you'll see the questions related to. One with respect to function being undefined but having a limit, function not having, the points having no limits and becoming unbound, and third is where it's a limit, it's defined also at that point. Let's say in this case x equal to, let's say, 3 is defined. So even if 3 happens to be a limiting point, it's contiguous in nature, it doesn't break, it remains defined. So you'll say this here the function on this point, this function is defined, and the limiting value is equal to value of the function. So far okay? Not okay? See, I scared Tanvi enough that this girl dropped off. Did I scare everybody else as well? Asvita, Praneeth, Dhanushri and Vishal, and here Sahit and Narush, okay? Nothing scary? Okay. How about you, Asvita? Did I scare you, beta? No? And are you guys, oh, okay. Tanvi, I was just talking about you. Probably you ensured 100 years for yourself, and I wish everybody gets 100 years, okay? So I was saying that Tanvi got scared of me when I was talking about all these stupid concepts.
No, sir, I had an internet issue.
Okay, not a problem. But you guys got these three flavors, right? Three flavors, okay? You will have function at any limiting point. If you see it being contiguous and not being undefined, it's a regular function with valid values. You have some limiting points where the function becomes undefined. That is where you will say you have limit, but it becomes undefined at that point. And you will have these scenarios where the function will go out of bound actually. Where on this point, when you travel from left to right or right to left, when I say travel, meaning when you change the value of x and move towards right from left, or from left to right, meaning you are increasing the value of x or you are decreasing the value of x, at that point you will see that your value of the function of x or value of y on that point where it becomes undefined, there is no connection between them. That is where you say they go out of bound. It's like a bomb blast happening on this point where it kind of spreads your thread, and the ring that was connecting here in this scenario, the two ends of the thread, that gets spread across. Yep. So now let me not blabber further on this. Let me give you guys some real questions that you will actually face, and then we'll see whatever we talked about or whatever we tried learning, is that helping us deal with those kind of problems. Let me read some of the questions that I have listed down for you guys. And again, some information for you guys. Don't follow this though. What happens is, when I'm driving back home from work, right, I go through some of the questions. I'll play whatever I'm trying to prepare for the class, and when my phone is on, the GPS is on. When I take a picture of something from my phone, it puts the picture of the GPS and the question both. Okay, you guys don't have to do that. That is not a good practice, driving and doing something simultaneously. But I'm just telling you that if you guys see some GPS with with the photos that I sent or the questions I put across. That is primarily because when I'm driving and taking screenshot, I don't know why, but it takes both the things. Okay, so don't get confused about why you see the GPS in the things that I put across. Okay. Now look at this. There is a question says you have been given the value of x and fx. Okay, when x is 0.9, fx is minus 7.11. When x is 0.99, it is minus 6.11. When x is 0.999, fx is minus 6.01. When x is 1.001, it is minus 5.99. 1.01, it is minus 5.89. 1.1, it is minus 4.89. The question is, what is a reasonable estimate for limit? What is a reasonable estimate for limit x approaching 1 for fx? So, whatever right or wrong concept I taught you guys, try recalling that and look at this question. What this question says is, you have value of x and fx given, fx as in y. When x is 0.9, this is minus 7.11. When x is 0.99, it's minus 6.11. When x is 0.999, it's 6.01. When x is 1.001, it's minus 5.99. So it says, and then it goes on, saying what is a reasonable estimate for limit of x approaching 1 for fx. What do you guys think? Yes, Vishal.
-6.
Yeah, that is one answer. Okay. I'll come to you, Vishal, to understand or to pick your brain why you think so. Okay. Anybody else? Dhanushri, Tanvi, Aswita, Praneet. And trust me, this doesn't need any calculation. Just has to be related with what we have just tried learning. What is a reasonable estimate for limit x equal to 1 for fx? Give it a shot. Tanvi, Dhanushri, anybody? See, I did not give the 4 choices, okay? If I would have given that, it would have been much easier for you guys to figure it out, okay? But I'm just letting you guys know, kind of stress out your neurons a little bit and read this data, okay? So Vishal, do you want to give it a shot? Explain me why you think it's minus 6?
I think it's because it's like, so it's getting closer and closer to -6. Like when the 0 point, like between the numbers, like when it's going from top to bottom, like it's getting closer and closer to -6. Yeah.
So, okay, and let me plot it this way. Okay, I just plotted it. So Vishal, see, the observation you made is correct here. What it says, when x is equal to 1, so here, Arush, everybody here, inside, look at this. When x is approaching 1, meaning it's asking us to find out the limiting value for function of x. Okay? When x equal to 1. Now look at this. When you're essentially talking about these two scenarios. Yeah? When x is 0.999 and x is 1.001. So your 1 will be somewhere here between these two, correct? And what you are seeing here is the difference between these two are pretty close. If you visualize that in a graph, let's say when this was 1, what you're seeing is they're pretty close. So if you are given 4 options, -6, -3, -2 and not defined, you see that it is falling in this range. Yeah? Not convincing. No, it's okay. I mean, I can come back to the same topic, but I'm first trying to make sure that everybody is with me. Sahid, do you think it's making sense, beta, or you would want me to double click on this?
It's making sense.
Making sense? Arush? You don't seem to be convinced yet. And that's important for me to know. Do you think it's making little bit of sense? Okay. Let's pick up another question, okay? Probably that might uncover okay. And this kind of problems, right? What I will request you guys is that whatever we have done so far, right? Just open Khan Academy, go to Unit 10. This is the first chapter in this one, okay? Don't study, just go to the quiz for that one, okay? And then try to look at what are the kind of problems that you have, and are you able to relate to what we have discussed just now? You might have to watch the video of the class one more time just to be doubly sure. But then try doing the unit test and come back to me, because this is the building block, okay? It might be confusing in the first go, but with couple of iterations of this, once it becomes a little more friendly, or what do you call it? And I don't know if I'm drawing it right or not. 1, 2, 3, 4. -1, -2, -3, -4, -5. Let's say -6. It says, what is the reasonable estimate? Okay, now look at here the question. It says, what is the reasonable estimate for limit x approaching -5 of fx? Or let's say here, since I'm considering this with this, so I'll say -6. So when it says, what is the reasonable estimate for this function when x is approaching -6? This is where we have x equal to -6. And you have, let's say, 4 options. Fx equals, let's say, -2, and here it is 4, equal to -2, fx equal to 4, fx is not defined, yeah, let's say fx equal to 8. These are 4 options you have. Reasonable estimate for x is approaching -6. Fx is -2, fx is 4, fx is not defined, or fx equal to 8. Which option you would lean towards? Everybody heard the question or no? I have this graph. This is my x-axis. This is my fx or y-axis. This has two parts to it. This wave that you see here is ending here, and I have a white circle here at x equal to -6, and then this graph continues here at x equal to -6 again. So what is the question says? What is the reasonable estimate for function of x when x is approaching -6? And these are your options. And when you say reasonable estimate, right, it always means that what is the value of the function or the value of y at the point which is just before this one or just after this one. I'm just thinking that I have probably got you guys more confused than explained something. What do you think, Asvita? Confusing or something? I'm sorry.
I'm like,
Uh-huh.
I understand, but I'm just like thinking.
Okay, okay. How about you, Dhanushri, Vishal, Tanvi, Praneet?
Yes, sir.
Yeah, what's going on in your mind right now? Which option you are leaning towards? 1, 2, 3, 4. Reasonable estimate for any function in a limit scenario is what will be the approximate value when you are reaching that breaking point. Here you have to find it for x equal to or x approaching -6.
It's not defined because
It-
the open circle.
It's undefined because you see this is discontinued at this point. There is no ring connecting the two ends of the wire. Yeah. So first of all, it's anyways undefined because there is a white circle, and then it is also out of bound, or it is. So you can say this is, and there is no limit. You can also say if you have given the option that okay, it's not defined, it has no limit. So this has no limit because limit your ring limits it. Okay, it limits from breaking it apart. Your ring is here, your wire is here. There is no limit. First of all, this is not defined because you see a break here at x equal to -6 or when x approaching -6, and then there is no ring connecting them. So you will say that there is no limit and it is undefined. So since you have the option this being undefined, you can simply go and choose that. Does it make sense, Vishal, Tanvi?
Yeah.
Yeah.
Yes.
So again, with 1 hour of solid blabber, what I have conveyed is that any function that you talk about, you will come across 3 possible scenarios. 1, when the function is continuous, you put a value of x, you get a legitimate value of y. That is 1. Contiguous function. You will have a scenario when the function breaks or becomes undefined. So at that point, on that point, you will see that the value of the function becomes undefined. Third scenario that we talked about was you have a function where at the limiting point where the function becomes undefined, you will see that the two ends get split or move away from each other far apart. When you see the two ends of the break being far apart, then you will say that there is no limit. There is nothing limiting them to stay together. Okay? Here, a situation like this, when you see the two ends at the point where it becomes undefined, moves up away from each other, it's a scenario when you'll say, first of all, this is undefined because you have an undefined value, and then when the ends move far apart, you will say that they have no limit to keep them together. Yep. With this lame definition of the functions and limits, I would request you guys to do the unit test for this one. Then you'll probably find 5 or 7 questions on Khan Academy. Okay, go to go to college prep and high school and college prep in Khan Academy. Go to pre-calculus. Inside pre-calculus, go to unit 10 and pick up the first topic. That's what we are covering right now, first and second topic. So both the topics that we have covered, you will find 5 to 6 questions in the quiz. Okay, try doing that and see if you are able to relate and solve them. Probably, when you do it by yourself, maybe me explaining it would be understandable, but when you practice it by yourself and by relating it with what we have learned, you should be able to solve those problems. And if you get all the answers right, if you're able to relate it, wonderful. If not, catch hold of me here. Okay, we'll come back to it again. Yeah, is that okay? Okay. With that being said, I'll let you guys go. Enjoy the rest of your dinner, rest of your evening. Have a good dinner. Take some good rest, and we'll meet again on Saturday.
Thank
Yeah.
you.
All right.
Thank you.
Yep. All right. Bye bye. Bye bye. Bye. Take care.
Sure,
Bye
bye.
bye.